Okay, question 3. This is a big one. We'll look at this. A lot of marks here. What's that? 10 marks. Oh, here we go. So let's have a quick chat what we're going to do. So we've got a polynomial. So that's when we've got something with a power of 3 for higher purposes. Basically, quadratic power of 2, polynomial for us power of 3. Then again, I think I've seen a power of 4, but anyway, power of 3 usually. When you see that, you should be thinking synthetic division. So that's your first one. We're looking at a synthetic division for that. Then they've got a little graph where they're asking about the roots, so we can then integrate to work out this area. So we've got some polynomial work, tiny bit of graph work, and then it's integration. So let's do the synthetic division first of all. So synthetic division, set up your I don't know what you want to call it, your bus stop or whatever, inverted bus stop. And what we do here is we write down the powers of our polynomial, bearing in mind it has to go from highest to lowest, and if there's a gap, we'd have a 0. So if this didn't have an x term, that would be a 0. Okay, it wouldn't then be 2, negative 9, 14. In the same way, if there was none of these last two terms, I would still need a 0 and a 0 at the end as well. Okay. The number we put in here is the actual root that we're looking at. Okay, so negative 1. If I put in negative 1 here, show that that's a factor. This is the root that goes in. So we change the sign of the bracket. That means, looking at that, that's going to be our negative 1 in there. That's going to be our actual root. So remember, that's the actual root that goes in here, which is the sign change from this. Okay, and the first thing we do, we just start off writing 2. We pull that down. And then we're multiplying and adding. Multiplying, adding. So 2 times negative 1, negative 2. Add them together, multiply. Add them together, multiply. And then we end up with a 0. And we'll say here the remainder is equal to 0. Therefore, x plus 1 is a factor. Is a factor of 2x cubed, take away 9x squared, plus 3x plus 14. Okay, so we know that we've got a factor, that's very nice. And all that means is that root is what is on the equation. So to solve it, we say, okay, well, if I rewrite this equation that I've just effectively divided by that, I can now say I've got x plus 1. And then this is the next bit of the equation. So that's going to be 2x squared, take away 11x, plus 14. And to solve it, I'm putting it equal to 0 and effectively factorising it. So what I'll do is I'll go off to one side and I'll factorise that big trinomial itself. Okay, so I'm looking for a number that adds to give me negative 11 and multiplies to give me 28 because I'm multiplying these two terms together. So that sounds to me like, was it 7 and 3, 7 and 2, 7 and 2, 7 and 4, there we go. So 2x squared stays where it is, the 14 stays where it is, and I break that up into negative 7x and negative 4x. Okay? It doesn't matter which way you write them, but to make my life easy, I try and write the similar numbers together. So take away 4x and take away 7x. So see, these two are in the 7 times table, these are in the 2 times table. But it doesn't matter what order at all, it doesn't matter. Equals 0. I'll just show this over a tiny little bit. There we go. So, next what we do, we draw a little line down the middle, and we'll factorise. So I've got 2x is my common factor, so it's going to be x take away 2, and then I rewrite my bracket, x take away 2. What do I have to put in front of it to equal this? Well, I'm going to have to times it by negative 7. Absolutely, and then put the two things together. So there's 2x take away 7, so they just come together like that, and x take away 2, fantastic. So that's me factorised that. So I'm going to go back to the beginning now and say, right, add that. I can rewrite this way. Very good, and that means my final answer is our x is negative 1, x is 7 over 2, and x is equal to 2. Those are all my roots of the equation. And if we were to look over here, that would mean then that is my 2. Honestly, that's my 2, isn't it? Because 7 halves is bigger than 2. And that's going to be 7 over 2. And that's actually what the next part of the question is asking. It's saying what's point A and B. So there's your A, there's your B. Yeah. Yeah, but time to do the integration. So for this bit, that's really straightforward. This is the hardest form of factorising, so we can do that really, really good. Sometimes this will not factorise, and if that doesn't factorise, you have to do b squared minus 4ac, which should come out as less than 0, and you would say b squared minus 4ac is less than 0, therefore it does not factorise, and that would be your final answer. Okay, so sometimes it can't go any further, but you'd still have to say that. So let's do some integrating then. So we're integrating between our 2 and our -1. Don't forget when you're integrating, you can only do above or below the line at one time. So for example, if I wanted both these areas, I would have to do that separately. I couldn't do them together. This would come out as a negative area, which I would then just write as a positive area. So if that came out as 2 and that came out as -1, I would say my total area is 3. So it's a negative area because it's below the axis, but you wouldn't take it away from 2. So watch out for that. And then we'll write a function down. So I'm integrating 2x cubed, take away 9x squared, plus 3x plus 14. And I'm integrating with respect to x. So don't forget to write that. And the next thing I would do is I would just remember what I'm doing with integrating. So I always write, x squared goes to 2x. When I'm differentiating, so when I'm integrating, it's the opposite. Add 1 to the power and divide. Okay, add 1 to the power and divide. So let's see if we can do that. I'm going to put a little box down here. That should be enough space. Okay, so add 1 to the power and divide. So it's going to be 2x, add 1 to the power and divide. Yeah, 9 stays where it is. Add 1 to the power and divide. Yeah, add 1 to the power and divide. And that becomes 14x. Fantastic. Now I think I'm just going to simplify that slightly. So that's going to be x to the 4 over 2. Take away 3x cubed plus 3 over 2x squared plus 14x. So that sounded nice, and then it's all about the substitution. So let's put in, again, this should be about the right size. And don't forget you're taking away, okay, so substitute in there. So I'll call that 2 to the 4 divided by 2, take away 3, 2 cubed, plus 3 over 2, 3 squared, plus 14 times by 2. This, again, there's a lot of work here. Once you get to this part, I think you're doing quite well. You've got most of your marks, actually. So please don't stress too much. If you don't like this bit, get the substitution. If you don't like the bit after this, get your substitution in. And then don't stress. Okay, the next bit takes a while, and it's not worth many marks. This is us done all the heavy lifting now. Okay, so we just need to start solving this. Yeah, I just checked the marking scheme now. So there's a mark for this, there's a mark for this, and a mark for this. So right away, without doing all your horrible work, you get 3 out of 4, so that's pretty good. But anyway, this is going to come out as 8, take away 24, plus 6 plus 28, and you're going to take away half, plus 3, plus 3 halves, take away 14. Watch out for all these double, triple negatives. That's a negative, and that'll come out as -1 times by the negative going to be 3. So just watch that, and that's going to come out as 18, take away -9, so you're going to end up with 27 units squared. Fantastic. So watch out for all those, 2 times 2 times 2 times 2, divide them by 2, really take your time, 2 times 2 is 4, times by 3 is 12, right? Take your time working through in your head, write out nice and neat, don't be a hero, and you should be okay. But this last bit is worth 1 mark. And to me, sometimes the fractions can get quite involved, there's a lot, easy to make a mistake. This is where you want to get your marks, okay? Don't forget your dx, you'd lose a mark for that. Take your time, add on 1 to the power, divide by the new power, okay? And write this, believe me, when you're doing differentiating and integrating in the paper, at one point you're going to get confused, okay? If you want to check it's done right, differentiate it and you'll end up back where you started, yeah? So just take your time with that. And yeah, that's a really good question, that one. There's a lot covered in that. So you've got your polynomials, you've got your graph work, and you've got your integration. Yeah, excellent. I'll just quickly see if I can get the marking scheme for this bit. So yeah, you get a mark for doing your actual work, and then a mark for the final comment. So don't forget your comment. And then mark for this, mark for this, mark for this. Hope that was helpful, guys. Thanks.